We're going to take a look at number 51 here. They've asked us to multiply and simplify. And before we get started on that, I want to make a point about multiplication of radicals. And I discussed this earlier. If you had, let's say, radical 3 plus radical 6, you would not be able to add these because what's under the radical sign has to be exactly the same. But, okay, if you had radical 3 times radical 6, you can multiply. And that would give you radical 18. Or you could write this as, move this up. You might see the perfect square lurking within that. So let me just approach this two ways. I multiplied 3 times 6 and got 18. Another way that sometimes it's more convenient is, here's the 3, okay, and 6 can be written as 3 times 2, okay, and this is all still under the radical. So here I could just say, well, I have 2 of a kind, so 3 times 3 is 9. I can take the square root. If I have 2 of a kind, I can pull out a 3, and this 2 is left in there. All right. Similarly, if I write it in this form, you might have to realize, okay, 18 is made up of 2 times 9. Okay, so I can rewrite 18 as 9 times 2. You don't have to have the 9 first. I just tend to do that. And then the square root of 9 is 3. Let me zoom out just a second here. And the 2 is left under the radical. Okay, so either way you would get to the same place. All right, so I just want to make the point. We can multiply if both terms or whatever are underneath the radical. But adding, addition, and subtraction, everything has to be identical. Okay? Now let's go ahead and jump into, what are we going to do, number 51 here, and I'll zoom in a little bit. Alright. Usually what I'll do is just take, if they're asking me to multiply, I don't feel like multiplying 18 times 32. So I'm just going to write that under one radical, and I'll kind of work up here. So that's 18 times 32. All right, and then I'm going to look for a perfect square in there and in there. And even if I don't find a perfect square, as long as I can rewrite it, I might be closer to getting something out of there, to simplifying what we're given. All right, so 18, you just saw this. That can be written as 9 times 2. All right, and then let's see our 32. How can we rewrite that? We could say that 32 is 16 times 2. Okay, and you can something gets out from under the radical if it's a perfect square or you have 2 of a kind. All right, so the square root of 9 is 3. The square root of 16 is 4. And here we have 2 of a kind. So we take the square root of 4 and we get 2. Again, 2 times 2 is 4. The square root of 4 is 2. All right. Now for our final answer, you have to multiply. It's 12 times 2 is 24. And that's our answer. If we had started out by multiplying 18 times 32, we would have gotten whatever 24 squared is. Maybe I'll show that to you real quick. Let me see. Just to do my calculation, I'll zoom out. I just want to show you, you get the same answer, it's just more work. Alright. So 24 times 24. So this would be equal to, under the radical, 576, and the square root of 576 is 24. Okay, I think that's a much harder way to go. We'll also take a look at number 53 here, and we'll zoom in a bit. Oh yeah, we'll take a closer look at this one. Get some of this out of our view. Okay, anything next to a grouping symbol means to multiply, so this is radical 2 times each term that's inside. If I had more terms, the radical 2 would simply get distributed to more terms. All right, so radical 2 times radical 18, I'm going to write that as radical 2 times 18. At this point, if you wanted to write 18 as 2 times 9, that would be a good idea. Or you could multiply and get 36. Problem with sort of illustrating working with radicals is there are many ways to proceed. All right, so 2 times this 6, radical 2 times radical 6, that's 2 times 6. All right, so for the next step, I'll just rewrite. The 2 is the same. 18 can be written as 2 times 9. All right. This 2 comes down. And 6 can be written as 2 times 3. And now, if you have 2 of a kind, square root of 4 is 2. And this square root of 9 is 3. This plus sign comes down. 2 of a kind. 3 is trapped. So we end up with something off the paper. I'll zoom out a little. And we'll have 6 plus 2 radical 3. And there's no radical here, so I can't combine them. If I had 6 radical 3 plus 2 radical 3, I would be able to add them. All right, now we're going to take a look at 54 and 55. All right, we'll check out the last two here. For number 54, I think I'll give you a similar one before I do this. If something's in front of the radical, it can only multiply whatever's in front of the radical. If something's under the radical, it can only multiply what's under the radical. Okay? So I'm going to just give you an example that might be a little bit easier to see first, and then we'll come back and do this one. Just real briefly, 2 radical 3 times 5 radical 7 minus, I'll say, 9 radical 11. So when we do this, the 2 times the 5 gives you 10. Whoops, sorry, I'm off my screen here. So 2 times 5 gives you 10, and then 3 times 7 gives you 21. All right. Then you send it into the next term. 2 times negative 9 is negative 18. And then underneath the radical, 3 times 11 is 33. You don't have the exact same thing under these radicals, so you can't add or subtract. Okay? It's basically the same thing down here with 54. You just need to realize that sitting in front of each radical, there's a 1. Okay? So I'll be multiplying 2 times 1 and 2 times 1. Alright, let's slide this up. Maybe we can zoom in one. There we go. So this 2 radical 7 is going to multiply our first term, and that will give us 2 radical 7 times 11 is 77. I just went ahead and multiplied them because I know there's no perfect square lurking within 77, because 7 is a prime and 11 is a prime. Alright, then when I send this over to our next term, I have 2 times 1. That gives us plus 2. But notice what happens here. I get 7 times 7. I could write it as 7 times 7. I could have just as easily written that as 49. Either way, 2 of a kind or a perfect square, however you want to think of it, gives you a 7. Alright, it made it out. If you have 2 of a kind, you get out from under the radical. So this is 2 times 7. And over here, 2 radical 77. And so your final answer is 2 radical 77 plus 14. And now we'll get to our last one here, number 55. I'll make a comparison first to some operations that you should be pretty familiar with, and that is, notice you have a set of parentheses with 2 terms, a set of parentheses with 2 terms. So this is actually going to work out just like when you had, let's say, x plus 5 parenthesis x minus 3 parenthesis. You're going to be following the same pattern. Parentheses next to parentheses means to multiply. Whenever you multiply, each term in this set of parentheses has to hit each term in this set of parentheses, just as if you were working with this expression. Okay? So when we did this before, I'll follow the same pattern. So you would have x times x would give you x squared. X times negative 3, negative 3x. Then across the bottom, you would have 5 times x, which is plus 5x. 5 times negative 3, negative 15. And as you recall, oftentimes these middle terms can be combined. So when we put them together, we'll get plus 2x. And these others I'll just bring down. We have our x squared and negative 15. Alright, so observe it's going to be a very similar pattern. Well, I guess I could have put a coefficient in front of my x to really drive home the point. Here you have a 7 in front, so this is similar to what I'm doing, but I failed to put a coefficient in front of my leading x. And we'll just proceed. So when I multiply by the first term, that's 7 times 1. So that will, let me make sure I'm still on the screen. So that's 7. And then radical x times radical x. I'm going to put x squared. X times x is x squared. Notice it's still underneath the radical. I could have written x times x either way. And then when I multiply by this negative 9, I can multiply 7 times negative 9, and that gives negative 63, but this radical x just comes along for the ride. Okay? So we've taken care of the first two, and now the second two. 6 times this radical x. This doesn't have a radical, and this has, the number in front is a 1. So 6 times 1 is 6, and radical x comes along for the ride. And then 6 times negative 9 is negative 54. Okay. Let's try to keep these separate here. And just as before, we can combine these middle two terms, okay? Because I have radical x. So when I combine them, I get negative 57x, negative 57 radical x, okay? Negative 57 radical x, all right? Then I'm basically going to bring this down, but the square root of x squared is x, and the 7 is sitting in front, okay? And negative 54. All right. So we multiplied and simplified.